Hey everyone, it's Ben from Board to Bits, and welcome to part 11 of our series on making custom 3D objects in Unity. So in this video we're going to start talking about how to make voxels the right way. Right now when we start our game, we are rendering our voxel object based on the data that we have. However, we're not doing it in a very efficient way. And the reason for this is that we have a very kind of simple program running here, and what it's really saying is it's looking at our data. If the data is a 0, then it's an empty space. If it's a 1, then that space is kind of filled in. So we're saying if 1, then make a cube. And when we make a cube, all we're saying right now is for every face of the cube, just make that face. We're not doing any more considerations at that point. What we really need to do is say for every face, we need to check and see, is that face visible? If that face is visible, then make a face. Because there's going to be a lot of faces. If two cubes are next to each other, they both have a side that is completely hidden from the viewer, that they're never going to see, so there's no reason for us to be making those sides of the faces. So we need to create a more intelligent way to kind of speak about our data so that we can make these sorts of kind of more detailed decisions about how much of our cubes we actually have to render. So in order for our program to make these more detailed decisions, we really need to make it possible to kind of speak about our data in a more detailed way. And for this we need two things. The first thing we need is a way to talk about the directions in our data. We need to talk, if you might recall actually, when I was building the cubes and I was kind of setting up the faces of those cubes, we broke them out into a north, east, south, west, and then up and down faces. And we need to actually, it's going to make our lives a lot easier if we kind of code that in or make a way of speaking about that in our code versus just having it listed out in an array. And so we're going to do that through an enum that's going to kind of give us that actual language to work with. Secondly, we need our data to be able to kind of be a little bit more aware of what its location is. Right now we are iterating through our data, but it really, all it's looking at is the data within that given cell. It doesn't really care if it's on the edge of our data, what its neighbors are, what data our neighbors are holding. So in order to do that, we really need to be able to give our data a way to look at a given cell and be able to kind of look to its side, see if there's anything there at all, and if there is something there, what the information that neighbor is holding. So that's really what we're going to be doing in this video, is kind of building out that foundation so that our data is much more robust and we're able to get a lot more information out of it. So back in Unity, we're going to open up our voxel data script in MonoDevelop. And here's where we're going to add all this information, because it's really going to be about getting more information, like I say, from our data. The first thing I'm going to add is actually going to be outside of the class itself, but I'm going to keep it in this same file because it's really, they work hand in hand together. This is going to be a public enum, and I'm just going to call this direction. And in here, we're just going to populate this with those 6 directions that we talked about when making our cube. So we're going to have north, east, south, west, and then up and down. You can obviously do these in any order. If you had done them in a different order in your cube script, you probably want to make this follow that order, because now we're really going to be relying on the fact that north is first, south is the third index, so on and so forth, to be building our structures dynamically. Save that quickly. The nice thing too is that because this is outside of the voxel data class, we'll be able to access that when we're making our procedural voxel, we're rendering our voxels out without having to, dive into the data every time. Next thing we are going to build actually inside of our data class, and that's because this is going to be when we're looking at cells, we're also going to be able to look at our neighbors. So we're going to do that here, and we're going to actually create a public function that's going to return an integer, much in the same way that when we're getting a single cell, we're just returning whatever that data is up here. We want to do the same thing. If we had a more complex class for inside of our arrays, we might return that whole class. But right now we're just going to return the data that's inside of it. We're going to call this get neighbor. And in order to do this, we're going to pass in the location our current location. So I'm going to say int x, int z, and then we're going to give it that direction. And we'll just call that dir for short. So we have to be careful when getting our getting these neighbors, because it's very easy for us, especially in such a small set here, but in any set, to get a outside of array error, which is to say that if we are, say, on a cell on the westmost border of our data set, and we try to look to the west, there's not going to be anything there because we're outside of the array, and that's usually kind of a deal breaker for Unity. It's going to, or for C# in particular, it's going to say, there's nothing here, I cannot proceed with this function. Like, it's not something I can kind of overlook or pass in a null value. It's just going to not work right now. So in order to do that, we really want to, before we look at that, try to look at that location, we need to see that, get those coordinates and say, are these coordinates something that is inside of our array? And in order to do that, it would be nice if we had kind of a contained space that we can look at coordinates. So I'm going to create that inside of here as well. I'm going to call this, and this one I am going to create inside of the voxel data class, because it's really only ever going to pertain to our data set. And so this I'm going to make it a struct called data coordinate. And this is just going to have an integer, public int x, public int z, and then we're going to do a quick constructor here as well. Public data coordinate int x, int z, and we'll simply set this dot x equal to x and this dot z equal to z. And so whenever we create one, it takes in these two pieces of data. We also, it would be nice if we had set up, now that we have this nice enum here saying, oh, we know that, the 0 index is always north, the 2 index is always south, etc. We can set up a way of looking at our coordinates. For example, we know that north is always going to be +1 on the z-axis and +0 on the x-axis. So rather than having to put in a number of conditional statements, it'd be nice if we just had that data stored somewhere, and then we can just say, oh, get me the north offset. And we can do that pretty easily, actually. We can do that right down here. In addition to our data coordinate struct, we can create an array of data coordinates called offsets. And in here, we're simply just going to create a list of new data coordinates that will work as follows. Oops, not brackets. We're going to create these using our constructor here. So a new data coordinate, first one is the north one, which I said before is +z but 0 on x, so 0x, +1z. Oops, comma, not semicolon. New data coordinate. Next one is east, which is going to be 1 on x, 0 on z. Now why is, oh, whoops, because I did not put an equal sign. That's why I'm getting errors there. There we go. Now we're actually creating these. Next one will be coordinate. Oh. Fortunately, MonoBehavior also likes to, for some reason, add brackets when you're creating new array elements. It likes to create those square brackets, not exactly sure why. So south will be -1. I need a y value. I'm thinking because I'm just using the x and z values on the on our grid, but we still need the y value for the top and bottom faces. So we do need to add int y up here. Apologies if anyone was wondering what I was doing here. And I'm kind of switching gears a little bit, so make sure that we have, and then we need a public int y up there. So our data coordinate structure has an int x, int y, int z, and our constructor takes in an x, y, and z. Now we need to also add our y values inside of our new data coordinates here, which the first 4 are just going to be 0 on the y, so that's going to be nice and easy to fix here. Next one's going to be west, which is -1 on the x, so new data coordinate, -1, 0, 0. And then lastly we have the up and the down, which are simply going to be 0, +1, 0, and lastly 0, -1, 0. Again, this is an arbitrary order I have chosen. If you want to do it differently, feel free. But now what this gives us is we have this way of saying, hey, we can, without going into our data and accidentally pulling something that doesn't exist or is outside of our array, we can get those coordinates, kind of look at those for a second, consider them, make sure whatever coordinates we have are still in our array, and then build, and then check if it is indeed something that's actually existing data. So with all this information, we can now say that our data coordinate, we'll call this check offset. So this is going to be kind of like, this is that offset from our current location that we're going to check and make sure that it exists. And we're going to So now in our getNeighbor, the first thing we can do is we can actually check, we can get our proper offset coordinate, whatever that may be, based on our direction. So we'll say data coordinate offset to check equals offsets. We're going to cast our direction to an integer. I'm not 100% sure, actually. I'm going to probably, let's see here, is this? Now, why is this giving me, oh, is it that way? Yes. Make sure you put a semicolon at the end of your array because this is really just a variable. This is not a function we're creating, this is a variable definition. So first thing we're doing, like I say, is we're creating this offset check that is really just pulling the appropriate, make sure if we're looking east, pull this particular data coordinate here. Now I believe we need to cast this to an integer so that we're actually getting an index from our array. Let me try deleting that for 1 sec. Let's see if Unity throws an error. Yeah, it can't implicitly convert direction to integer. So what we can just do is we'll cast that right there. Okay. Cast that to an integer, so now its offset's getting the appropriate index. Next, we're going to actually get our neighbor's coordinate. We'll do that by saying data coordinate neighbor coord equals, and this is going to equal a new data coordinate, which will be our x value, so our current x value, like where we're looking from, plus the offset to check dot x. Y we know is always 0 right now because we don't have a y. It's a single. There's only one layer of y. There's never, y doesn't go up or down. So we can just say 0 plus offset to check dot y. We do still need to add that in because there is, when we are saying if we're going to render the top of our cube, we are going to be looking above our cube. It's going to show that there's no data there, but we do need to make sure that we're adding that in. And then z plus offset to check dot z. Now we have this neighbor coordinate. Now we can look at this and quickly check and see, is this in our data array? And we know, how do we know if it's not in our data array? Well, we know because an array goes from 0 to some number. We know that if it's anything below 0 on the x, y, or z, then it's outside of our array. Likewise, if it goes above, if it's equal to or above the actual length of the array, then we know that it's outside the array. So we can simply check on the x, the y, and the z values, is it too low or too high? So we can simply say here, if neighbor coord.x is less than 0, or neighbor coord.x is greater than in width or Now, y is kind of a funny situation here because we know y is always going to be 0 if it's in the data, because we don't really have a y dimension. So what we can actually just say here is if neighbor chord.y does not equal 0, if it's positive, if it's positive 1 or negative 1. Now, why is this not giving me... Oh, I think it's just because this is open, and so it's not knowing what to do with all of this data down here. This will be okay. If it's not 0, if it's negative 1 or positive 1 or anything else further than that, we know that it's not in the data. If neighbor chord.z is less than 0, whoops, and this should be greater than or equal to width, and likewise neighbor chord.z is greater than or equal to depth. So if any of these things is the case, we don't even need to look in our data. We know we're outside our data. We're beyond the borders of the map. Just return. We also know in that case that it's empty. So we can simply say if it's any of those things, return 0. Just pretend that there was just an empty cell there, even though there's no cell at all. Otherwise, we can actually get that cell and return its value, which we can simply do by using our get cell call. So we can say else return data dot, do I have data? Yeah, data dot get cell. Oh, not even data dot, sorry, just get cell. Return get cell, and we can pass in our neighbor chord.x and neighbor chord.z. And so now what this is doing is saying if our neighbor chord, like I say, is outside of our bounds, then just return 0. Otherwise, actually return the neighbor. Simple enough, makes sense. So right now we're not actually going to see any change in our actual structure here because we're not changing how we render it yet. That's going to be in our next video. We're now going to take the fact that we're able to look at these, check and see what the situation is of our neighboring cubes, and be able to more fine-grained render our cube, only rendering the faces that it really needs. So that will be what we get into in our next video. In the meantime, thanks for watching, and I'll see you next time.